Today we're doing Eureka Math Module 5, Lesson 11, and you can see that our learning goal is exactly the same as yesterday. Just like yesterday, we're going to be working on finding the areas of rectangles by tiling, drawing, and multiplying. Okay, we're adding on to what we learned yesterday. We're going to take the basic concepts of what we did yesterday, and then we're going to make it a little more complex, a little bit more challenging. Just like yesterday, we are going to find the area of these rectangles by tiling them using square units. Go ahead and locate your square units. Remember, for our square units, we're using Post-it notes because they are a square unit. Right now, tell your table group how you know that this Post-it is a square unit. Okay, let's start by figuring out how many square units we can put across the length. Okay, so go ahead and figure that out. How many square units fit across the top length of your rectangle? 3.5. So you can see we're not done tiling the whole rectangle yet. We're not rushing ahead to tile the entire rectangle. We're just doing one row. Please follow along. So what is the length then of this rectangle? 3.5 units. Good. Now, figure out how many can go along the width. Go ahead and do that. Okay, so now we can see again that the width is 2.5 units. So if you tile the rest of your rectangle, you'll see how many square units fit on your entire area of rectangle A. Now that we've tiled our rectangle, we can start to count how many square units we have. How many whole square units do we have? 1, 2, 3, 4, 5, 6, right? Okay, so we have 6 holes. How many halves do we have? 1, 2, 3, 4, 5. So we have 5 halves, right? How many fourths do we have? Okay, so we could add 6 plus 5 halves plus 1/4. Are we ready to add? No. Why not? Do we have common denominators? No. What would be the least common denominator between halves and fourths? 4. So instead of 5 halves, we could write how many fourths? 10 fourths. Very good. Okay, so I have 6 plus 10 fourths plus 1/4. That means we have 6 and how many fourths? Good. Is 11 fourths a improper fraction? Yes. How many holes are there in 11 fourths? 2. So this is 2 and 3/4. So this is 6 plus 2 and 3/4, which is 8 and 3/4. What would our units be? Units. What kind of units? Square units. Very good. Go ahead and write that down. Now, what if I wanted to use multiplication to check my answer? How do I find the area of a rectangle, Luke? What do I need to multiply? The width by the length. Good. So what's the width? 2.5. What's the length? 3.5. So if I multiplied 2.5 by 3.5, that would also give me the area. Do you agree? Am I ready to multiply? No, because I have mixed numbers. Let's make them into improper fractions. 2.5. How many halves does it take to make one whole? 2 halves. 2 halves. So if I have 2 holes, how many halves is that? 4. So this 2 is the same as 4 halves, yes? But I add 1 more half, so how many halves do I have altogether? 5. Okay. How many halves are in 3 holes? 6. Plus 1 is? 7. So I have 5 halves times 7 halves. What's 5 times 7? 35. What's 2 times 2? 4. Okay. How can I simplify that? How many holes do I have? 8. How many fourths are in 8 holes? 32. So if I take away 32 holes, or 32 fourths, how many fourths do I have left? 3. 8 and 3/4. Is that the same answer? Yes. Okay, so this is how you use multiplication to check. Very good. So for rectangle B, as you might recall, this last spot right here, I didn't know how big of a piece of square units to cut. Okay, we figured out that from here to here is 1 square unit, yes? Yep. From here to here is also 1 square unit, and from here to here is also 1 square unit. So far, how many square units did we have there? 3. But over here, from here to here, was not 1 square unit, was it? How big of a square unit was it? 3/4, okay? Let me ask you a question. How far is it from here to here? From here to here? 1. How about 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 from here to here? 3/4. How about from here to here? How about from here to here? How about from here to here? Here to here? Here to here. Good job. I didn't trick you with the colors. Good. How far is it from here to here? How far is it from here to here? Good. Here? Here? Good job. Trying to trick you. It didn't work. How far is it from here to here? Do you see how based on our tiling we can see all these different dimensions? So therefore, this missing piece, it must be 3/4 by 3/4 or 3/4 of 3/4. Go ahead and write in your tiling and then also figure out what the area is. How can I figure out the area? Well, I just have to add up 1 plus 1 plus 1 plus 3/4 plus 3/4 plus 3/4 plus 3/4 plus 9/16. Go ahead and do that. What is the length of rectangle C? 1 and what's the once again, what is the length of rectangle C? 1.5 units. What is the width of rectangle C?
3/4 units.
How can I use multiplication to find the area? Sawyer?
6/4 times 3/4.
Yeah, 3/4 times 1.5, right? Which is the same as 3/4 times 3/2, which then Sawyer skipped a lot of steps. He said 3/4 times 6/4. Can you guys see how he got there?
Yeah.
So what's in the numerator?
3 times 6.
Which is 18. 4 times 4? So 18/16. Is that improper fraction? It's 1 and 2/16, or square units. Okay, but how could I use what I've already found to find the area as well? Well, we know that the area of this part right here is 3/4 because we have 1 times 3/4. Do you agree? We also know the area of this part is 3/8 because we have 1/2 times 3/4. So how could I do it? I could add 3/4 plus 3/8. So 3/4 plus 3/8. Am I ready to add? Not yet. I have to write an equivalent fraction to 3/4, which is 6/8, plus 3/8, which is 9/8, which is
1 and 1/8.
1 1/8. Very good. Check.